Okay, so we are learning roots now. B is our base. To the nth power is equal to some number. We can say that B is an nth root of A. Let's put numbers in there so it makes sense. If 3 to the 4th is equal to the 81, by the way, it's not like if. 3 to the 4th is equal to 81. Okay? That is saying that 3 is a 4th root of 81. That is telling me that 3 times 3 times 3 times 3 is 81. Is that a proof? Is that what you said? No. Yeah, the wording, yeah. So here's an example. If 2 to the 5th is 32, then 2 is a 5th root of 32. We write an nth root like this, where n is. So I'm going to write my two examples like this. If I'm talking about 2 being a 5th root of 32, I will write a 5th root like this, and that little n value becomes something called an index of the radical that tells you what kind of root we're doing. And I'm doing a 5th root of 32. That's equal to 2. That's telling me if I take 2 to the 5th, I will get 30. So the first example that was all filled in for us, same thing. We're doing a 4th root. So I'll make a little root, put an index of 4 in there. That is a 4th root of the number 81. What to the 4th is 81? 3 to the 4th is 81. Okay. Example A. A 4th, stop interrupting my class. A 4th root of 81 is written as 4th root of 81, where, oh, this is what I just did for you, where 4 is the index of the radical. Just did that, okay. Now, we're going to discover a couple things real fast. These are the only calculator questions that we're doing today. Nah, I lied. There's another calculator question later. Square root of 9. You can probably do this without the calculator. 3? Okay. Probably without the calculator, but probably not. Can you do 9 to the 1/2 power on your calculator? I'm looking for my calculator. You have not done fraction roots before, or fraction powers, so it's not going to magically come natural. 9 to the 1/2 power is 3. How about square root of 2? That I'm going to have to do in the calculator. Square root of 2 is approximately 1.414. Okay, it's approximate. What is 2 to the 1/2? 2 to the 1/2 power. Approximately 1.414. Oh, what's the next one though? The cube. Show you how to do cube root on your calculator for all of us that brought our calculator. We go to the word math, which is right here. And there's actually a cube root option. And then I'm going to type in 8. And I'm going to hit enter and I get 2. The cube root of 8 is 2. That is telling me 2 to the 3rd is 8.
Does that mean
All right, how about the next?
Like the radical. What's like the what is it? It's the end. Is that what it's called? Like the term that goes with the radical.
The index.
The index.
The index.
Yeah, so it's the reciprocal. The index is the exponent that equals the same thing. Yeah.
Yes. Sure. Okay. So here, if I'm doing the cube root, the third root of 4 squared, hit enter. It's a horrible answer, but that's okay. Ultimately 2.5198. And then if I take 4 to the 2/3, I get the exact same answer. What do you mean by up? Like, so you can see the top part?
Yeah.
Okay, so that's down to me, but I know I thought you meant up.
If like 4 to the third over 2.
Type it in your calculator.
Like, would it be improper? Never mind.
Do you mean 4 to the 3/2?
Yeah.
I wouldn't call it improper, no. But it's going to give you a different answer than this would. So Chris has kind of came up with his own little discovery, and he's told me about it, so I know he understands it. But, like, can you come up with something that has to do with the index number when it's in fraction form? Because all of these were the same for each of those. They're all equivalent expressions. The square root of some number, x, is the same as that same number to the 1/2 power. That's true.
Okay.
What is the index number on square root? What's this number that goes right here?
That.
What kind of root is that? What's the nth root for square root?
Square.
2. This is the 2 root. We just don't write it because, like, that's one we always use. And you see how that went to a denominator. So, Chris, when you were saying the thing about the reciprocal, like, it didn't 100% work what you said here. Kind of talking about the 3. Right? Okay. So what I have here is an explanation saying the radical symbol, which we're calling b. We've got whatever we're taking the radical of, it's called the radicand. The space inside of the radical is called the radicand. We have an exponent inside there. We can rewrite this as a fractional exponent or a rational exponent. There will be questions that you will prefer to work out as fractions. There will be questions that you prefer to work out in root form. So we have to know how to switch in between them. This is what I was always taught as a young Algebra 2 student. When I talk about, I'm just going to make something up. This is the 4th, I'll use the one from up there. 5th root of 32. You guys just heard me say this. This is the what root of 32? The 5th root of 32. If your name was called, go to the door. Where, I don't know. You probably shouldn't be. We're not going to talk about it right now. Okay. Where do roots grow? Down. That way, right? So when we rewrite this I'm going to change it even. I'm going to write it like this. Okay. When we, oh gosh, that's better. I'll do it with this one first. Okay. When we rewrite this as a base to an exponent that is a fraction, bottom, that's where the root goes, because roots grow in the ground. So that's where my 5 goes. What goes on top is power. Like, you guys might have those power lines that are up there. Power lines go up there. Some people believe there's a higher power up there. Power goes up here. So the 1 that's written here is going to be here. That's how we switch them. So look at this example. I'm just going to make it bigger, the one, number 7 and 8. When we go to switch this into a rational exponent, we keep the same base. These is the root. When I say this, I say the what root? I say the third root. Okay? This is a root. This is a power. This is to the second. That's a power. So when I rewrite it, where do roots grow?
On the ground.
Down that way. So the 3 goes down here. And power.
Above.
So that 2 goes up here. That's how we switch in between the 2. Just showing you how to switch them. Okay. This next is a calculator for a lot of this. A handy list until you know them, because you did so many practice questions that you should know them by then. Let's write down some powers of 2 and some powers of 3 and some powers of 4 and 5, just so the ones that you'd probably need to know. You should know anything to the first power. I'm not going to write that down. Okay, 2 to the second is, it's going to take us forever, 2 to the third, 8. And then 16, 2 to the 5th is 32. We just talked about it 4 times on the front page, or second page. 2 to the 6th is 64. 2 to the 7th is 128. And maybe a 2 to the 8 might be in there. Maybe. Not really that much. 256. I just did 8 of them. The ones that I see a lot would be like from the 7th down. Maybe a 2 to the 8th in there, but not so much. 3 to the 2nd. 9. 3 to the 3rd. 27. 3 to the 4th. 81. 3 to the 5th is 243. And 3 to the 6th is 729. I'll never have bigger ones than that. Unless it's calculator. 4 to the 2nd. 16. 4 to the 3rd. 64. And 4 to the 4th is 5 squared. 25. 5 to the 3rd is 125. And then 5 to the 4th? 620. It's just helpful to have these in your notes. Some others, what? Some others, we might do 6. Well, you guys should already know the squareds. I'm not going to write down any squareds now. But 6 to the 3rd is 216. Gosh, what is 7 to the 3rd? 343. I knew it wasn't 243. That one I don't think happens that much. And then 8 to the 3rd on very rare occasion, like that's 512. But one of them you should definitely know. 10 to the 3rd. 1,000. So here's a handy list, but A lot of these you're going to keep seeing over and over again, and if you've seen them over and over again, then they're going to show up on quizzes and tests without calculator. If we never see 512 once, then that will definitely not show up. Okay. All of this is going on a video. We're going to find an nth root. This is telling us the index.
Oh, I thought you said
Third root of negative 216. Third root of negative 216. One thing I didn't talk about was, no, this is not imaginary. If we have a cubed, 3 negative numbers equals a negative. So it's okay to take a cube root of a negative. So just think, what's the third root of 16? 6, but it's actually going to be negative 6 times negative 6 times negative 6. So this is asking you to set it up and write the answer. This is kind of stuff you're going to have at home. Yeah. Okay, so then here's of 81. Yes, but I'm pretty sure, I have to go look at my book, I'm pretty sure when we don't know a lot about what's going on here, if it's even, that it could be either. If we put the square root in ourselves, we don't know if they want the positive or negative answer, so it could be plus or minus 3.
So you want us to write it that way?
If it's even. If the index number, if the n is even. Because if it's odd, we can have a odd, we could have 3 odds under there, or we could have 3 evens, and it doesn't affect. No, I'm saying that wrong. If it's like if it's even, 4 negatives make the same answer, but like 3 negatives or 3 positives make 2 different answers. It's the evens one that has that extra step. All right, so here's some more practice ones. Okay. Now let's do some real, if they're fast. 4th root, I was thinking, but then let's just do it. 4th root of 16. Do I need a plus minus?
Yes.
Okay. So then I have plus minus. What is the 4th root? 2.
Wait, how do we find this so quick though?
I have them memorized.
Oh.
The what is
Oh,
16.
Okay, we just.
You got to memorize them to do them fast. Yeah. Okay, so this one says the nth root, so the 3rd root of negative 125. Do I need plus minus? So what to the 3rd? Negative 5. I know, I just. But. Huh? Oh, this one? This one? Okay. So we got plus or minus. It is an index of 2, which you can have to write because it's square root of negative 49. It would be plus minus 7i, but this does say root. And these are imaginary, so I just wrote no real roots. But if we were finding the answer, it would be plus minus 7i. Okay, and then 5th root, do I need plus?
No, you don't have.
Okay, 5th root of 243.
243, 3.
Yes.
Yeah, 3.
I mean, there's some that you can tell right away it's not going to be 2. And it's not going to be 4, because those are even numbers. It's not going to be 5, because it'll end in a 5 or a 0. So I pretty much only have 3 as my option, unless it's one of those weird ones like 7. But if I'm making you do it by hand, you're going to have practice with that. All right, this is probably the part that most people get confused. They take time to do. It's not bad. Write good directions for it. Okay? I think looking at the explanation is confusing. Just follow my directions. the first thing I'm going to ask you to do is I'm going to ask you to prime factor, wait, factorization, prime factor, the base. So in this 16 to the 3 halves, what is the base?
16.
Oh yeah, did you guys notice this? I made it like really big.
No.
We're doing this without a calculator. That's why I'm trying to give you the best, easiest way to do it. So we're going to factor the base, which is 16. So 16, that's like what? 4 and 4? But I'm doing prime factorization, so those get broke down more. So 2, 2, 2, and 2.
Or could we do 8 and 2?
You could, but 8's not a prime, so you got to go further.
Oh, okay.
When you go prime factorization, every single person, no matter which path they took originally, should get the same answer. 2 to the. So we're going to rewrite 16 as 2 to the 4th. So I'm using a substitution property that says if 16 is the same thing as 2 to the 4th, I'm going to rewrite it as 2 to the 4th, exponent, 3 halves. So all I did was substitute 16 for a smaller number with an exponent. Now we're going to use our exponent rules. If I have a base and I'm doing it to a power, what do I do to their exponents? I'm not sure if people answered me. Oh, you did say multiply? I couldn't hear. So we're going to multiply 4 by 3 halves. How do I multiply a whole number with a fraction? Gosh, we reviewed fractions, didn't we? Put 4, don't say it, put 4 over 1, right? And then what do we do to multiply?
Just straight across.
Straight across. So now I have 2 to the 12 over 2. So now I have 2 to the 6. And what's 2 to the 6? Let's see. Oops. So first we prime factorization, we substituted, then we multiplied our exponents. And then we just like simplified. That is much easier. 16 to the 3 halves power. Did you know that was 64? I can show you how to do it a different way. I just think this is like the easiest way to do it. Let's try another one. Oh no, that was a negative.
Should it be 9 and 4? Wait, sorry. When you did the prime factorization?
For 32?
Yeah.
No.
So you have to do 16 and 2?
You can do 16 and 2. It's not 9 and 4 though.
Oh, 9 and 4 is 36. Yeah, negative 2.
That's what I was like, no. All right, so let's take that 32 and factor it, or maybe it's on a list that we've been making, wherever my list went. Might even be on one of these lists we've been making. 32 anywhere on that list? What is it as prime factorization? 2 to the 5th. Okay, but if you didn't know that, you could do 2 and 16 and then. So 32 is 2 to the 5th power. And we're going to multiply that exponent with negative 3/5. We're going to multiply those. So I've got 2 to the 5th multiplied by negative 3 over 5. Put 5 over 1, go straight across. So I get negative 15 over 5, which is 2 to the negative. So what does the negative exponent tell me?
Reciprocate the base.
It means reciprocate the base, and the base is
2.
2. So we'll have 1 over 2 to the 3rd. But can you find out 2 to the 3rd?
Yes.
So we should probably find that out.
27. No, sorry.
8.
I don't
You just yell things out before you think a lot. Yeah. He needs to fix that before becoming a cop, though. That you are going to, so if you're waiting for people to catch up. No, we might not have time because we had to go over a lot of questions at the beginning, where my other class, they didn't have to do those. They're not going to have to do those questions. Okay, so evaluate without using a calculator. Can I factor down 4?
Yes.
2 to the second. 2 to the 5 halves. So I multiply my exponents. I get 2 to the 10 halves. 2 to the 5th. That's 32. Daniel, are you trying these? I know. I'm going to factor to be 3 squared and raise that to the negative 1/2. Multiply my exponent 2 times negative 1/2. So I get 3 to the negative 2/2, which is 3 to the negative 1. So 1/3. $81. Anybody know that one? 3 to the 4th. Sometimes, yes. Let me just put that off to the side. 9 seconds. I'm going to multiply that by 4ths. My next would get 9 to the 6/4, which is 9 to the 3/2, and I'm still something I can't do without a calculator. So if you take it down to the smallest prime number, it's going to be, you're going to be able to do it every time. So 9's not a prime number because 9 could be factored further. Right, so I multiply this together, I get 3 to the 12/4, which is 3 to the 3rd, which is 27. Last one. Not on these. That's the only time you have to like write in the radical yourself. Well, I don't even have a radical here, but they are technically radicals. All of these are. Like for fun, write this one. Let's write this as a square root, or not square root, as a, as a root. Out of the 7 and the 8, out of these two things, which one is the root?
7, no 8, sorry.
It's the one that's in the bottom where roots grow. So if I'm writing this as a root, I'm putting an 8 here. I put the base underneath, and I put the power of 7. It would still be 1. So I'm doing the 8th root of 1. Does anybody know the 8th root of 1 by any chance?
8 to 1.
Yeah. It's like 1 to enter is 1.
You didn't have to do any of that. You could have just looked at it and said 1 to the power.
All right, so these next ones, I do not think I need to go over. It says evaluate using your calculator around decimal places. Yeah, those are all use your calculator. This is the last thing I just need to touch on. It says find the real solutions. So for like example, we're going to find real solutions. What will I do to solve for x first? We're going to divide by 4. Get x to the 5th equals 3. Not a nice answer. I'm going to leave it. I'm just going to leave it as 128/4 for now.
It's 32.
Why can't I do that? Okay, because I was carrying something and never mind. Because I'm trying to hurry. That's why I couldn't do it. Okay. And then how do we find what to the 5th power equals 32? What did we do when it was a square here before? So we're not going to do a square root, though. A 5th root to both sides. Do I do plus minus if it's odd?
No.
So I don't need plus minus. X is 2. 5th root of 32 is 2. Okay, well there will be a video, so you can, and maybe you'll get this and you won't need it. How do I do this one? I need to get x by itself, but something's around the x that I got to get rid of first. You cannot distribute it because this is subtraction.
What? How did you just put, wouldn't it be x to the 4th power?
Square root it over 4.
Oh, yeah,
You get
Oh,
the
man.
square root is.
So we are going to 4th root both sides. So I'm going to 4th root both sides to cancel out a power of 4. These are opposite operations. However, it is even, so I will have a plus or minus. What's your question, Daniel?
Oh, I was going to say, but 4, then it will be negative 81.
You cannot distribute over addition or subtraction. That only works for multiplication division. Okay, what you would have to do is you'd have to write 4 of these and multiply all of them out, and I'm not doing that. So now we're going to add 3 to both sides. And can I show you how to do 4th root on your calculator? Because I think they ask you to round it if you need to round it. I'll show you how to do 4th root. I didn't show you 4th root yet. If you have your calculator, you're going to go under, well, let me go ahead and hit 3 first. 3 and then plus. Then you go under the button that says math, and there is a 4th root. However, there is an x root. If you have the newer calculators, which you don't, do you, Chloe? Okay, so I'll help you in a second. If you have the newer calculators and you hit 5, things already there's boxes, and you can plug them in. So what do we have? 4th root, 21. Oops, 21. Enter, super easy. Chloe, what you're going to have to do, does anybody else have the older one? You have the older one.
I got it here.
Okay, the ones that did you try the,
Yeah, but it doesn't let you. It doesn't X.
okay, so what you guys are going to do is you're going to do like your 3, then you're going to do your plus, then you're going to hit the 4th root first, you're going to hit 4. Then you're going to go to math and do that x root. I don't think mine's going to work if I try it that way, but you guys try doing the x root, hitting 21. Oh yeah, no, it's actually the end of that. It's in the book, but I put it on the end of it. Did it work? Did it work?
Yeah, it works.
Okay, if you have questions, I'll come answer them, but your assignment is in the book. However, if you scroll down on your notes, I even copied the book on your notes. Or you could go on Big Ideas Online and get to the book that way. And the numbers that you're doing are on Canvas. Don't look, it's great. Don't look, I don't know.
Oh wow, nice grade.
Trying to like get all that real fast. But the notes are here. We did not get to the flip grid activity. I think I'm just going to have to throw that in for you guys because I think my next class is going to get to it, so I'm not going to take it down. But you're more than welcome to read it, and if you want to work on that, you can. But those are the questions that you're doing. It says you're doing like all of these, or if that's bothering you, you can just do 1 to 43 all.
So is it a assignment?
It is not on Big Ideas, it's on your own paper. So you can either do 1 to 40 to 18, 21 to 24, 25 to 31 odd, 33 to 34, 35 to 43 odd, or just do 1 to 43 all. Your choice.
And that just means a little more work.
Yes. But people complain when I write all the numbers out. So I put this on them.
Hey,
Great.
What's up?
You're going to do 1 to 43 or you're doing the first one? Let's see if I can trick you.
I was just I'll give you one question you don't have to do that.
Do you want make a fraction?
She's ordering it basically was transfer on her.
1, 2, 4.
Two though. Alpha, white, and gold. Easy. Come on. This is more work, but
What's a good thing? You know it's on Canvas, bro.
Yeah, I'm gonna write it down.
he printed it out, so he does not want to have to open up Canvas.
Oh, listen.
My back is
What? Why would you put 1 to 43 on?
Because as soon as I put up the first assignment, people complain. That's so much. So I say, fine, then do 1 to 43 odd. No, but they complain because I made it look
I'm trying to show, like,
oh my god.
yeah, I get what you're trying to say.
That's like a pet peeve of mine, so I just covered my base. Now they can't complain because he could do one or the other.
That's my Chromebook.